Okay, thank you very much. It's always different when you're up here. For example, you can see me, but I actually cannot see you because of the lights, but we'll make do. So I wanted to talk about the state of the art of AI. I realized I only have about 17 minutes, so I decided to focus. 20, okay. Let me slow down. Good morning, Manishma. I'll talk about, thank you, Avner. I'll talk about the state of the art in AI. And I want to tell you just a little bit about AI2. We're a nonprofit research institute founded by Paul Allen in 2014. We're based in Seattle. And at this point, we have about 100 researchers and engineers. We have intern programs. We have an incubator, all kinds of things. What's more exciting is I have the pleasure of announcing today, for the first time in a public setting, the launch of AI2 Israel. It's in... Thank you. It's very exciting, and it's our contribution. Earlier, the professor was talking about the government of initiative to put Israel on the map internationally in AI. This is our small but unique contribution, and it's in Mitcham Sarona in Tel Aviv, right by the train station, if you want to stop by. We are hiring outstanding people. This is the email if you want to find out more or send your CV. And our focus is, at this point, very much on natural language processing. Already we have Ron Yachini, who's actually here. He's an entrepreneur, venture capitalist, and business executive. He's the chief operating officer of the institute in Israel, if you want to talk to him. We have Professor Yoav Goldberg, who shares his time between Bar Ilan University and leading the scientific direction of the institute. And we've hired a number of people and interns. So we're getting going. If you want to find out more, this is the URL for AI2 Israel. So I want to tell you more about things that we're doing, which involve research and engineering, and give you some specifics that you can use. We have quite a few projects in natural language processing, in vision, various challenge projects. We have Semantic Scholar, which is a major scientific search engine available for free 24/7 if you want to try it out on your phones. Currently, it covers computer science and biomedical sciences. If you have a medical condition you want to look up, this year we're expanding it to all of science. But let me get more specific and talk to you about 2 or 3 very exciting initiatives that you can use yourself. Beaker, which is an infrastructure project, Allen NLP, which is an open source framework, and as I mentioned earlier, Semantic Scholar. So what is Beaker? It's a platform for doing rapid reproducible research, specifically in data science or machine learning. And what we realized from our own work is that if you're a data scientist, but you're not conversant with provisioning machines on the cloud and copying terabytes or petabytes of data without that breaking, it's really painful to do the management of machines and data sets and experiments. So we created a project that we're soon going to make publicly available, and it provides you with simple commands to run experiments as opposed to the low-level commands you might find in AWS. It provides easy tracking of experiments. I'll show an example in a second. Organization of all your experiments or collaboration with other people in the organization. And for example, the key idea is that an experiment is an object, and the object is addressable by a URL. So all you need to do to share an experiment with somebody else is share a URL using the Beaker platform. And all you need to do to run an experiment is issue a command, kind of like the one you see on the bottom. You go to Beaker, you create an experiment based on a particular recipe. I won't go through the details here because of time. I'll just give you the flavor of it. So this is what an experiment looks like. If you want to see in more detail, we have a bunch of metadata associated with it, and this is, as I said, addressable by URL, so it's easy for you to take something like this, modify it, rerun it, and so on, again, so long as you're on the Beaker platform. Long story short, we're enabling you to focus on the AI and data science and let the plumbing underneath be worked out by the Beaker system. The concept is very simple. The implementation is complex. And of course, other folks, if you're familiar with Amazon SageMaker or Google's AI platform, other folks are coming to market with this sort of ideas. There's an even Israeli-based startup called Comet ML, if maybe you're familiar with it. Okay, let me switch and tell you in a little bit more detail about Allen NLP. I'm not sure if I can see, but how many people are here work with NLP or interested in NLP? Okay, good. So a non-trivial group. I'll tell you about this, and even those of you who aren't, you'll quickly get a sense of what is the state of the art in NLP. So the basic idea is, right, these days, data science and NLP and vision in particular is very much driven by frameworks. A lot of people are using TensorFlow, PyTorch, systems like that. Allen NLP is built on top of PyTorch, and it tries to answer the question, what sort of high-level components can I give you to make you be able to do your research a lot faster? And what we do is we first of all have a declarative syntax. I'll give you an example in a second. And you can specify an entire experiment using JSON. So here's an example. Let's say I want to have an encoder. It's an LSTM encoder. Hidden size is 200. The number of layers is 2. The dropout parameter is 0.5. And it's a bidirectional LSTM. I just specified that using this declarative syntax, and the point is, if I don't want it to be a bidirectional LSTM, all I need to do is change that true to a false, and I'm done. We also provide a lot of other abstractions. If I want to change the encoder to be a GRU encoder with the same parameter, again, I just change a keyword. So standard application of declarative syntax, but it's built on top of key abstractions in NLP. We have LSTM, we have attention, we have a variety of things. There are so many ways to do training and streaming and so on. If everybody does it a different way, it makes it hard to understand the code and to modify it. So we provide standard abstractions for all these things, for tensor multiplication and more. In addition to that, Allen NLP, and by the way, if you want to check it out for yourself, go to allennlp.org. We also have there more than 20 state-of-the-art models for open information extraction, named entity recognition, et cetera, et cetera. And we have also a set of interactive demos. So even if you're not an NLP person, if you want to get a sense of what works and doesn't work these days with NLP, you can access these state-of-the-art models at our website. And a big deal for us is Elmo. Let me talk a little bit about that. So again, those of you familiar with NLP know that these days one of the key breakthroughs there is the mapping of words to vectors of context. The original form of that was word to vec, and we've made a lot of progress in this direction. So basically, if I want to know what is the meaning of a word and how close is the word king to the word queen or the word Israel to the word Eurovision, I can look it up in a vector space. What we've done is we figured out that you can do this with a vector that represents the context and the task that you're involved in. So a word like Java, right, that can be a programming language, or a cup of coffee, or an island in Indonesia, will be represented differently based on the sentence that you see it in, both in your corpus and also in the real-world task. Now, this makes a difference because when you plug this sort of thing into a variety of tasks, like named entity recognition, coreference resolution, et cetera, you get a very large boost in performance. Since Elmo was created last year, it won a Best Paper Award. Google created a follow-on system called BERT that allows you even better performance. and this is continuing, right? This is some people call it Muppetware, right? We have Elmo and Bert, Ernie is coming, and we're creating the next version of the Muppets, et cetera, et cetera. This is a very fast-moving field. The point is that all this is built into Allen NLP, so you don't have to retrain these things from scratch. You can use this as a component in your system. So to illustrate to you a little bit more what is available here and what we can and cannot do with NLP, I thought I would show you screenshots. I won't try to do this live over the internet, but this is all available at Allen NLP. I'll show you screenshots of the kind of question answering we can do based on a simple paragraph. So here is a paragraph about the matrix. You can read it quickly. It has the obvious facts. I assume everybody's more or less familiar with the movie The Matrix. And so we can ask it questions like, who stars in The Matrix? And the computer answers, the NLP system answers by highlighting the relevant parts of the text. In this case, a paragraph. So who stars in The Matrix? It gives me Keanu Reeves, Lawrence Fishburne, et cetera, et cetera. It gets that right. And now I'll ask it, what is Neo's profession in The Matrix? And again, you can see in the paragraph there, it doesn't say profession, it just said computer programmer Neo, and the system automatically realizes the computer programmer is a profession, it's Neo's profession, et cetera, et cetera. So it's quite impressive. Then I was trying to break it, so I asked, what is the machine's goal in the movie The Matrix? And again, it's able to highlight exactly to subdue the human population. And if you read the paragraph, you really see that the clues that this is the machine's goal are very, very limited. So at this point, I was quite impressed. I was starting to think, maybe I no longer have job security. You know, when you work in AI, you feel like you have job security, right? It's not going to be solved for many decades. And I started getting worried. Do I still have job security with this deep learning stuff? But fortunately, I asked it a few more questions. I asked, who is Neo fighting? And it happily answered, computer programmer, right? So it shows, you know, even if it seems to understand what's going on, you should really kick the tires a little bit, be a good Israeli skeptic, and you'll quickly find that it really doesn't understand at all what's going on. Who is Neo fighting? Computer programmer. How many actors star in The Matrix? The answer is 1999. So it realized it needs a number. It found the number, it was the year. It doesn't know how to count the number of actors in the list, and it got it wrong. Since then, we've been working on improved systems and improved data sets. So what's wonderful about these demos is before you listen to all the wonderful things, you get to kick the tires. Very, very important. Allen NLP is now pretty widely used in the United States, both by universities, organizations like the Facebook Research Organization. Yesterday I was at Hebrew University and I found out that they've started using it, and of course we're using it in AI2 Israel. It's freely available to you if you're interested. So moving quickly along, I wanted to talk about Semantic Scholar. Again, we have there open source and data, but the biggest use of Semantic Scholar, I hope to persuade you that you should at least try it for your own scientific and engineering research. So we all know that there's a Moore's law of scientific publications, right? The number of papers is increasing exponentially. It's actually remarkable. Somebody estimated that the number of AI papers on arXiv, the preprint server, is increasing actually, it's doubling every 18 months, right? So almost literally a Moore's law of publication. So it makes sense that we use AI systems to help fight this information overload, right? To have better filtering and better tools to allow you to home in on the papers you want to read. And so I'll quickly mention some of the features that Semantic Scholar has to help you. First of all, we have the search engine. We have a variety of filters. A lot of people also just search for a particular topic or a particular paper and find their way through Google or something like that into Semantic Scholar paper pages. At this point, we have about 3 million users, unique users each month. So it's becoming increasingly popular. The search engine allows you to use various filters, the author, the publication year. Are we talking about a review paper or a clinical trial or a conference paper? Who are the authors? What was the conference? These kinds of filters help you to home in. Not only that, but you can easily traverse the papers by citations. And often papers have thousands of citations, right, that refer to them. So we sort them by what citation is most influenced by these papers. You can really look at the important citations. When you have a citation, you can see what did one paper say about the other. You just hover with your mouse and you see the connections between the papers. It's actually a very, very handy tool. And it's not even if the paper is mentioned explicitly. Using natural language processing, for example, if it refers to the system name, like Elmo, doesn't include the citation, we still show you the connections. Another example is we also link the papers with millions of items of external content, including code, software code, including videos, including tweets, including blog posts. So if you're not sure, maybe you weren't at ICLR, but you want to know what's going on there, often the easiest way to catch up with the conference and different papers is to look at a blog post about it. So what Semantic Scholar is doing is taking that information and basically doing a join with all that content and the different papers. So over time, you'll see more and more of disassociated content, the video or the slides, whatever it is. So you can use that to decide, do I actually want to read the papers? Think about it. Each of us, the number of scientific papers we will read in our lifetime is limited, but the number of papers appearing is doubling every 18 months, right? So we need this kind of tool to help us decide, okay, am I going to take one of the, 3,000 technical papers I'm going to read in my lifetime? Am I going to dedicate it to this particular paper? Semantic Scholar helps you make that decision, I think, better than any other tool at this point. Another thing we do to help you is we automatically extract the figures and tables from each of these papers using machine vision techniques, right? Papers are available on the internet in PDF form, right? So they're not marked up exactly. We use a vision technique to look and see, okay, what are the figures and tables? That's very convenient to see. You can quickly go through those, look at them and see whether you want to read the paper or not. Last item, we're starting to also extract the key quantitative results, right? Sometimes I don't need to read the whole paper. I just want to know tachlis, what's the result? And we're using information extraction technology to go into a paper. This is the famous attention is all you need paper, and we extract the key result. Some of these fancier features are still work in progress. This is a research project, and so, right, the precision here is still 81%, and the coverage is less than 10%, but we are continually making progress. And again, if you're interested in collaborating with us or accessing our data sets, contact us at the email. Also, a lot of this is available on our website. We are continually releasing additional open source software. So to summarize, again, at the very high level, I talked to you about our nonprofit that shares code, data, and tools. I gave you some examples very specifically, news you can use. Hopefully you'll take this with you, share with your friends. And really what's under the hood here is a pretty unique combination of researchers and engineers. We don't have a hierarchical structure where the researchers sit there and say, okay, you engineer, data scientists do this for us. We really work shoulder to shoulder. And as a result, we have projects that have a combination of both cutting edge research and high value engineering. And encourage you to join us. We also do startups, at least in the US. I don't know if any of you are familiar with Xnor.ai. It's a startup that develops cutting edge vision models on chips at the edge, whether it's a phone or a camera or even a Raspberry Pi chip. There actually, I learned about recently an Israeli company that was in the news recently, I think Helio, it does something similar. It does it in hardware. The XNOR layer is fully in software, so it's potentially compatible with any chipset. Very exciting, and of course, we're in Israel, we're going to do some startups down the road as well. So to end, again, this is our URL. I'm also going to be, after the talk, available in the hallway, and so is Ron, if you want to talk to us more. Thank you very much.
Thank you, Dr. Etzioni. So, before the morning coffee break, please remember that we have 4 parallel tracks and one 50-minute IBM workshop track that will take place after lunch at 2 p.m. in Teddy D. Please pay attention to 2 changes in the schedule. The first one is that ML8 and ML28 were swapped, and the second one is to check out the additional talks we added after 5:30 p.m. To view the agenda digitally, make sure you download the Bizzabo app, and the ushers can help you and answer your questions if needed. Enjoy your coffee break that will end at 11 a.m., and please pay attention to the schedule. Thank you all, and have a fruitful and great day.